I want to talk about the alternating series test to decide if something is convergent. I will link at the end of this video a couple more in-depth kind of explanations of this. This is, again, just one of my try it series, so this is a quick overview. If a series is alternating, oftentimes it's got a -1 to the n, maybe it's an n plus 1 or an n minus 1. That doesn't especially matter. Just make sure it's not like 2n, because then it wouldn't be alternating, because if it was always to an even power, it would -1 to an even power would be 1. So verify it is alternating. -1 to the first is negative, squared is positive, cubed, and so on. We're going to do two things. The first thing is just kind of isolate the non-alternating part of this. It's 1 over n. If I stripped away the alternating part, it's 1 over n. And say, is the limit 0? And the answer here is yes, it is. It is 0. Then we know we have convergence. Okay? That's all that needs to happen. Now remember, that's not true if it's not alternating. But for this, that's all that needs to be true. That's step 1. Is the limit 0? Step 2 is take that same function without the alternating part and say, does the series 1 over n converge? Of course, the answer is no, it diverges. That's a divergent series. So we go back to this, and this other C right here, this converges conditionally. Converges conditionally, because it is convergent, but only because it was alternating. If it hadn't been alternating, it wouldn't converge. Let's do this next one. Again, I'm going to strip away the alternating part, just say it's 1 over n squared. Say, is the limit 0? Of course, the answer is yes. So it converges. That's all that, remember, that isn't enough for non-alternating, but it is for this. Step 2, that same alternating part stripped away series, does that converge? The answer is yes. So we say it converges absolutely. Converges absolutely, because even if it weren't alternating, it would still converge. This one, we'll strip away that alternating piece, limit, as n goes to infinity. Say, is that 0? The answer is no. It's not. It's 1/2. So this diverges. Okay, if the limit's not 0, it automatically diverges. Let's try a few. All right, pause the video and try to figure out if each of those converges conditionally, converges absolutely, or diverges. All right, let me show you my work. Let me remind you, if this video helps you, please like and subscribe for more math content and more of these videos. Step 1 is the limit 0. This one's a little harder to do, but the answer is yes, because the higher powered thing, factorial, is in the denominator. So right away, I'm just going to put this converges. Step 2, does this series converge? Well, if you use the ratio test, and let's see here, we'd have an extra 3 on the top and an n plus 1 on the bottom. So this limit, let me just put equals 0. This does converge. So this converges absolutely, because the series converges as well. Factorial in the denominator, it's probably a pretty good bet that it will converge. So converges absolutely. The limit was 0, and the series would converge even if it weren't alternating. Let's move on to the next one. Let's take the limit as n goes to infinity. You'll notice this limit is infinite. Higher powered things on the top. So this diverges. We don't even need to proceed. All right, next one. Take the limit as n goes to infinity. Higher powered things on the bottom, so the limit is 0. So this converges. I should just say in the AP exam, oftentimes they'll say, which of the following converge? That's enough. To be conditionally convergent is going to be enough. You don't really need to proceed if this were like a multiple choice or something. If the answer was just, yes, that limit's 0, you could be done. I would do limit comparison here to 1 over n, which is divergent. So this converges, but only conditionally.